particle aspect of radiation. Now, we are critically analyzing these, we are going to analyze these topics with this question that how classical fails to explain these phenomena, how quantum mechanics is successful to explain these ideas. This question is very important, and you need to keep it in mind every time whenever we discuss the various points of these experiments, being the representative of failure of classical physics. Okay, so particle aspect of radiation. In classical physics, what the physicists thought? They thought that particles are different entities, means we can represent a particle with energy and momentum. These are the characteristics of a particle, right? In classical physics, particle is characterized by energy and momentum. Whereas radiation or waves are quite different entities according to classical physics. I mean, both of these are exclusive from each other. They have no dependence on each other according to classical physics. And the classical physicists thought that particles can be dealt with some other theory, some other mechanism, and waves can be dealt with other way. Okay, waves have the characteristic wave vector k and some amplitude as well. So amplitude and wave vector are the characteristics of a wave, while energy and momentum are the characteristic of particle according to classical physics. And these particles and waves are entirely different entities, have different behaviors, right? You can say that they are mutually exclusive, and we cannot represent our radiation with a particle and vice versa, right? We cannot represent a wave with a particle or a particle with a wave. Both of these are entirely different from each other. This idea was floated by the classical physicists, and they thought never to overlap any characteristic of these two entities, totally different entities, particle and waves. These are totally different. But in the start of 20th century, this rigid idea of mutually exclusive waves and particles was destroyed by the modern physicists. They thought that this idea of the classical is ridiculous. This idea is a regress idea, and this is not a valid idea that particles and waves are entirely different from each other. But they floated the idea of particle aspect of radiation. As the name suggests of this article, particle aspect of radiation means radiation has some aspect of particles. Radiation can behave like particles. And these experiments like black body, photoelectric effect, and Compton effect, these are examples of the particle aspect of radiation. How we can deal radiation as a particles, and why is it necessary? We will answer these questions while detailed study of black body radiation, photoelectric effect, and Compton effect. Right?